Okay, let's practice writing balanced equations given the chemical reactions in words. So phosphorus trichloride reacts with chlorine gas, and it makes phosphorus pentachloride, and the phases are there, solid, liquid, gas. So this is what we have. Phosphorus trichloride liquid reacts with chlorine gas to make phosphorus pentachloride solid. Just wondering if more light will actually help our situation here. My new camera, and it's terrible. Resolution is terrible. Anyway, that's as good as it gets. To balance this, well, it is balanced. There, 1, 2, 3, 4, 5, and 5, 1 phosphorus, 1 phosphorus. So that was easy. Next, we have carbon monoxide. Carbon monoxide. So both carbon and oxygen are right there, top of the P block. They are each nonmetals, and so they form a covalent compound. It's not monocarbon monoxide because we only use the mono on the second of these binary covalent compounds. So it's the name of the element without prefix. If it's 1, if it's 2, it would be di, but this is 1. So carbon monoxide. You take the first syllable of the element name, oxygen, and you add IDE. So carbon monoxide gas and hydrogen gas. You need to know that hydrogen as an element, of course, is just H, but you need to know that hydrogen as a gas is a diatomic, which means 2 atoms. Other diatomics include the gas of oxygen, fluorine, chlorine, bromine. Those are diatomics. Nitrogen as well. I think I said that already. Makes liquid methanol. This is methanol. We did the alkane series in class. 1 carbon would be methane, saturated with H's. 2n plus 2, that would be 4. The next one is ethane. The next one is propane. The next one is butane, and so on. And so that is a C2H, 1, 2, 3, 4, 5, 6. 2n plus 2 is 2 times 2 is 4 plus 2 is 6. Propane, C3H8. 2 3s are 6 plus 2 is 8. So the little formula I'm reciting is CnH2n plus 2, because each carbon has 2 hydrogens, and then the 2 N's each have 1 more. Anyway, this one is methanol. So methanol is methane, but one of the hydrogens is replaced with an OH, and that makes it an alcohol, and so we hear it. Methan, instead of methane, you drop the E, you add the OL for alcohol. Methanol. Liquid methanol. 1 carbon, 1 carbon, 1 oxygen, 4H, 2H, 2, so that would be 4. And so we said in class that the coefficients in the order from left to right would be 1, 2, 1. Here would be 1, 1, 1. Yes, because when I don't write anything, it's assumed to be 1, which is true. But I don't write a 1. I leave it blank. But it means 1 CO plus 2 H2 gives me 1 CH3OH. So when we were just rhyming these off in class, we said, in that case, 1, 2, 1. This one is a decomposition reaction, which means that something, a single reactant, splits, usually when heated or maybe struck with ultraviolet light, for example, decomposes into 2 or more simpler products. So it's going to break down. These things form that in the reverse. Potassium chlorate, I recognize that as an ionic compound because I can hear the metal. So the metal is always the cation, and the second species is the anion, which may be a single nonmetal anion or an oxyanion, a polyanion, which this one is, chlorate. And you'll recall, let's use a piece of scrap paper, that we had in that series, the chlorine plus oxygen series, we had, well, not to start there, we actually had a ClO minus, a ClO2, and a ClO3 and a ClO4, all -1 as polyatomic anions in this series. And this one is the hypochlorite. This one was the chlorite. This is chlorate. And this is not hyperchlorate, but just perchlorate. Oops. So 8, and that is the convention that the ATE prefix has more oxygen than the ITE. But I don't just have these two, I have one on the other end. So more than chlorite is hypochlorite, or I should say less than this, because there's one less oxygen, and then one more oxygen is perchlorate. So back to here, I had potassium chlorate. Chlorate is ClO3 minus. Potassium is K plus. Potassium chlorate solid decomposes to make potassium chloride and oxygen gas. Is it balanced? No, I have 2 oxygen there and only 1 here. So I could put a 1/2 in front of this, but I don't want to leave a fraction. And so to get rid of the fraction, I multiply by what the denominator is, 2. So then I multiply everything by 2, and that makes this 1, because 2 halves are 1. So now 2K, 2K, 2Cl, 2Cl, 2 oxygen, 2 oxygen. Magnesium metal is placed in an atmosphere of nitrogen gas. So nitrogen gas is flowing over a strip of magnesium metal, and it's making solid magnesium nitride. So nitrogen is just before oxygen in the periodic table to the left, and its common ion is N3 minus. N3 minus. Magnesium is an alkaline, so that's Mg2 plus, and to make a neutral ionic compound I need Mg3N2. And so I need 3 magnesium solid in front of, see, here's nitrogen, another diatomic gas. 3, that's it. 311. 311. Dinitrogen oxide, also known as laughing gas. That's N2O. Dinitrogen oxide. That's a covalent compound between 2 nonmetals, so it's not ionic. And when solid ammonium nitrate, so ammonium nitrate plus minus, so it goes together neutral. I don't need the brackets because it's 1 to 1. When that solid is heated, it makes water and laughing gas, N2O. So ammonium nitrate, is this balanced? Nope. 2 nitrogen, 2 nitrogen, 4H, 2H. Now I have 4H, and I have 2 oxygen plus 1 is 3, and that's 3. Perfect. Ethanol. So I showed you what methanol was. So ethanol is, oh, sorry. I hope you saw the last one. I showed you what methanol is. Ethanol is ethane, where that would be an H. Ethane, knock off the H and replace it with OH, so now it's ethanol, which is C2H 6O. Liquid with oxygen makes carbon dioxide and water. Want to balance that one? I would start with the carbon, not oxygen, because if oxygen is in each, you can't start that way. You'll drive yourself crazy. It's carbon is only present here on this side and 1 on this side. So if it's, I would balance that. 2, 2, right? Okay. The carbon is balanced. Hydrogen, I have 6 over here and I have 2, so then I do 3. I always balance oxygen last in a combustion reaction, which is essentially what this is. And I adjust it with a coefficient here because I can change this coefficient and not ruin what I've done with the others. That's 4 and 3 is 7. So I have 1 here, which means I have 6 here. So if I do a 3, then that's great. So my coefficients are 1, 3, 2, 3. Combination reaction. 2 or more elements or compounds bond to form one product. So here I've got nitrogen and hydrogen gases. N2 and H2 makes ammonia. Remember, ammonium is NH4+, but ammonia gas is a neutral compound, covalent compound between nitrogen and hydrogen, which is NH3. Is it balanced? No. I need 3. That would give me 3, and I need 1. And I can't have fractions. So now I'm going to multiply through by 2. That'll make that 1. That will make that 3. And that will give that as a 2. So it's 1, 3, 2. That works. 8. A double replacement. So I have the cations are switching places. So copper chloride and sodium sulfide, they are going to switch places. So my product will be copper sulfide and sodium chloride, which is what I have. And it's copper 2, so it's CuCl2. Sulfide is a -2 ion, so it's Na2S. Chloride is a -1, and sodium is a +1, that's NaCl. Copper 2, and the S is a 2-, so that makes CuS, and that's going to precipitate out as a solid, although I didn't say so in the question. Is it balanced? Nope. Now it is. Lastly, a hydrocarbon substance is something made up of just hydrogen and carbon. And when you combust a hydrocarbon, it means that you are adding oxygen gas, excess, and forming clean combustion, CO2 and H2O. When it just contains carbon and hydrogen, or carbon, hydrogen, and oxygen, like a carbohydrate. We are asked to combust methanol. Again, that is CH3OH, so that's CH4O as a molecular formula, plus O2 gives me carbon dioxide and water are always going to be your products of combustion of a hydrocarbon or a carbohydrate. And now we need to balance it. And when I balance a bigger problem like this, a bigger, just slightly larger molecule, because it's a carbohydrate, I always want to start with balancing the carbon, because you see oxygen is going to show up everywhere, so it's the absolute last thing that you do. But balance the carbon first, so that's 1 and it's 1, great. And then the hydrogen. I have 4 here, I have 2 here. And then I need to balance the oxygen by adjusting this number, not that one, because that's going to then throw off my C and H, and I'm just caught in a loop. So I have 1, 2, 3 over here, and over here I have 1, 2, 3, 4. So I need this to be a 3. So if I do this, 3/2 of 2 is just going to be 3. But I don't want that fraction, so I'm going to multiply through everything by 2. That will make that a 3, this a 2, this a 2, and this a 4. And now everything is balanced, and so my coefficients are 2, 3, 2, 4. And that's it, folks. All done.